week, our meeting about uncertainty, there are two rules, right? We have addition and subtraction. We have multiplication and division. Right now, I am at multiplication and division. So first step as well. First step, before you answer your question is, I suggest you to go with the significant figures. So as you can see at here, each of the significant figures, there are two significant figures. So the least significant figures in this question is there are two significant figures. Okay, then you can calculate the R. So everyone understand that R is equals to V over I.
Wait, so shouldn't it be one significant figure because it's 0.5, 0.1?
Yes, okay, thank you. So the least significant figure is one significant figures because of the voltage. So at here, you have 0.5 divided by 2.5. So the answer is 0.2 ohm. So however, the rule state that you have to follow the least significant figure, right? So it's fine, you have one significant figure. Now, when you want to find the, what do you call that? The uncertainty, you have to make the unknown as a subject. I repeat, yeah. You have to make the unknown as a subject. So, okay, I make the unknown R as a subject. So you already have as R equals to V over I. Do you remember that I told you the power would be the coefficient? The power would be the coefficient, and I told you that you have to use the fractional uncertainty. You have to use the fractional uncertainty. So fractional uncertainty of the resistance 1 times fractional uncertainty of the voltage added with 1 times fractional uncertainty of the current. Any of the students want to ask questions until here? No. Okay. Now we continue. Yeah, we substitute the value. This one is unknown. The resistance is 0.2. 0.1 over 0.5. Uh, so 0.2 divided by 2.5. So if you go in this way, you're gonna get the answer 0.056. Okay, I need you to think, is it right for us to write the result as this? Will it be right if you write the result like that? No,
No.
because you decide this to be 1SF, and as you can see, because you decide as 1SF, it will be ending up with 1 dp. So, however, your uncertainty should be at 1 dp. Anyone want to ask questions? No? No? Okay. Can you take a photo of this first? Because I'm recording this. So Okay, I'll fill it up. Okay, the second case, the second example that I want to give you to recall what you have learned last week. Let's say, okay, we have this formula. Don't question me what formula is this. This is centripetal force formula. C is speed. R is the radius. So let's say you set up an experiment, you want to measure the centripetal force and stuff, and you get this data, for instance, 10.0 plus minus 2 Newton. The mass is 1.0 plus minus 0.2 kilogram. And the R is 0.3 plus minus 0.1 meter. So, okay, I want you to find the C or the speed. Remember, check the significant figure first. Okay, what is the least significant figures? This one, there are 3 SF, right? There are 2 SF, and there is 1 SF. So right now, keep in mind that your least SF is 1 SF. Okay, you can make the C as a subject first. So C is equals to square root of F times R divided by mass. F times R divided by mass, and you square root it. So try to calculate. The answer is 1.73. Okay, so if I want to write it as 1 SF, means I will write it as 2. Yeah. If I should write it as 1 SF, I will write it as 2. Anyone want to ask questions until here?
So what is it to instead of 1.7?
If you write as 1.7, it will be at 2
Oh,
significant
yeah.
figure.
Okay.
Okay, now I need mathematics. So we talk about power because the power will be the coefficient. So any of you don't understand if I say the power is half for all of the variables that here because it's square root. So fractional uncertainty of C half times this. Plus, but then that is division. Yeah, it's fine. Multiplication, division, the rule is the same, and there is no subtraction. So please do not think like, oh, if product means plus, if division minus. No. Okay. Okay, so no one have questions, right? The C are still used before changes on before being changed on. I take out the half. I assume you can do the substitution. I hope you have calculator with you right now. So yeah, at least you don't always just like listen. You can count also and can compare if we get the same result, same number here. Okay, so the next question is it right to write a final answer of this? Is this right? Wrong.
No.
Yeah. You have decided it to be 1 SF. And because you decided to be 1 SF, then you have no decimal place. You have no decimal place. So means your answer would be 2 plus minus 1 meter per second. Any question? Be right back. So anyone have question? No.
Sir,
Yes.
does the force have to be plus minus 2.0?
Sorry, which one?
For the ones that is given, does the DPS to match?
Yeah, that is the rule. Oh yeah, so yes, thank you. So I have to be 2.0. Is that what you mean?
Yeah.
Yeah, have to be 2.0 actually. Okay, now number 3. So let's say the third one. Okay. You are observing this. That is Newton. Yeah, I mean, there's a Newton. It's supposed to be capital. Okay. Okay, so I ask you to find the pressure. So the significant figures, each of them have two significant figures, right? 2.5 and 1.0, right? Remember, in this case, we have to make sure everything in SI unit. So your diameter, you have to write it as 0.01 meter. Your diameter, you have to write it as 0.0 0.0. Understand all here? Okay. Then you can count the pressure, or you can count the area separately first. So the area separately is 1/4 pi d squared. And after that, you can find the pressure. Try to use your calculator. Don't just depends on what I write. Okay, please. So okay.
Sir, 1.0 is how many significant figures?
Two significant figures. Guys, if you have any questions,
0.1.
now 0.1 is only 1.
So at the question you wrote 1.0 plus minus 0.1 centimeter. Is it fine?
If for a significant figures problem, we don't count the uncertainty, right? We only count from the data, the raw data.
Oh, okay.
Okay, so right now the pressure that I have is like this. And this is definitely wrong if you write like this. You have to make it become two significant figures. So you have to write this as 32,000 Pascal. So if you want to write in two significant figures, you're going to write as 32,000 Pascal. Any question? No. Okay. So pressure is equals to force over area. And as you can see, the pressure is the subject already, so we can go ahead directly. So yes. It will be like this, right? And for the pressure, I will use the raw data that I get at first. So this is given the question last time. I won't use the one that I round off. Now I want to talk about the area. Do you have any uncertainty for the area. Don't have, yeah? Well, you have written down an equations that area is 1 equals to 1 over 4 pi d squared. So let's talk about this version. Is there any uncertainty for 1 over 4 pi?
No.
No, okay. So I can write uncertainty of the area over area is equals to 2 times uncertainty of the diameter over diameter. Uncertainty of the area over area is equals to 2 times diameter over diameter. Anyone have questions? Okay, listen to this statement carefully. When you want to find the pressure, you have to make sure all in SI unit. When you want to find the pressure, you have to make sure all in SI unit. But when you are talking about the uncertainty, it's not necessary. Why? Because whatever the unit that you put in, as long as they are the same, then it will be cancelled out. In fractional uncertainty, the units are not important. So this is the number that I'm going to put in for the area fractional uncertainty. Try to calculate the pressure, the uncertainty. So the uncertainty of the pressure is around 7,643. Is it right if you write 32,000 plus minus 7643.3 Pascal? Can it be written in this way? No. Because you have decided it to be written in two significant figures. And because if you write it in two significant figures, you're going to round it off to the nearest 1,000. You round it off to the nearest 1,000. So this is a wrong way to write. So your final answer would be 32,000 plus minus. You should run off the uncertainty also to the nearest 1,000. Any questions until here? Okay, so this is the question for number 2. Now we need AMATS, actually. At least those who take AMATS, you will find out that in AMATS, that is one chapter we call as a linear law, where you express the y equals to mx plus c. So we need it in sciences. So probably your next question is why I have to sketch everything linearly? Why I cannot just do a scatter plot by using Excel and let the coordinates be a curve and something else? I wish I could explain further to you, but we have something to do with statistics, and I don't want to bring it to a regular class like this. So when you do an experiment, you will present your data and you will talk about how many % of your data follow a certain relationship that you suggest. So in statistic testing, it will be easier for a scientist to perform the test if the graph is linear. So that is the scientific explanation why linear law is important in additional mathematics. And now for those who don't take, you still can understand it actually. So if you read questions number 1, he wants you to plot R at the y-axis and On the other hand, you need to have a 1 over d square as the x-axis. So you can separate it, become something like this. So means this is the x-axis, this is your y-axis, and this is your gradient. So in EMATS also you learn linear law, right? So it means in this case, is there any y-intercept? There will not be any y-intercept. So the gradient is representing 4 times the resistivity times length over pi. That is the expression for the gradient. Any students have questions until here?
Sir, may you repeat about the gradient?
So after you separate the y-axis, after you separate the x-axis, then that will be the gradient because the gradient attached to x, right?
But why is it only for that equation?
Why is it what? I'm sorry?
Why is 1 over d square not included?
Oh, the 1 over d square is the x-axis. The questions has stated it have to be the x-axis. So we have a model y equals to mx plus c. So right, guys, sometimes I wish I can explain to you how the study will benefit you, but the scope, I cannot reach there. I mean, okay. So maybe when you learn AMATs, right, if you are not patient, right, you are questioning why I have to learn it. Yeah, so yeah, in the future you need it, right? I would say like that. Okay, this is the example. Okay, now we're going to discuss the part B. Include the absolute uncertainty for 1 over d square. So you have learned before this now, right? 1 over d square. This one you can write the, okay, I'm going to call this as a variable. Let's say I call this as z first. Okay, so z is equals to, let me ask you a question here. 1 is a coefficient, right? Does it have any uncertainty? Does the number 1 have any uncertainty?
Mm.
No. So I can write fractional uncertainty for z would be 2 times fractional uncertainty for d, because the power of the d is 2. Any students have questions until here? No. Okay. So it means the fractional uncertainty for z is equals to 2 times this times z. So what is z? Z just now is 1 over d square. Z just now is 1 over d square. Anyone have questions until here? No. Okay, please substitute in the value for the first one. You have the absolute uncertainty of d is 0.01. Please substitute in and try to calculate. Divide by d to the power of 3. Then times 2. Okay, so I get 0.0248. That is the fractional uncertainty. While you have to count the z itself also. The z is 1 over d square. So please count 1 over the 0.91 square. The answer for the first one is 1.2076. So have you tried to count? Any questions for the first one? Until here, any question? No. No. Okay. How many significant figures are there? Your D is 2 significant figures, right? 0.91, right? So can you write the final answer as 1.2076? You should have written it in the two significant figures too. I repeat that. You should have written it in two significant figures too. So 1.2 plus minus. If you write as a 1.2, how many decimal place do you have it there?
Wait, sir, how do you
Yeah.
get the 1.2?
Oh, because the 1 over d squared just now is 1.2076, right? Then miscalculate, we get the same.
Wait, the 0.0248 is which one? That one's the
The absolute
Uncertainty of
uncertainty of
Z.
the z. Yes, right. Right. That's why I hope you guys also count, not like depends on what I say. Oh, I miscount, yeah. 0.265, yeah, is it given?
I got for that one I got 0.0265
0.0265. Oh,
for
okay.
0.29945.
Okay. So, okay, thank you. So if I write as one decimal place, it means my uncertainty also have to be one decimal place, right? But I ever tell you already, right? We ever write as 0.0? Do we ever write the things as 0.0? Never. Never. Okay. I know you have to be two significant figure, but you have to like sometimes think also. So at here, I will need you to add one more significant figure. So become a 1.21 plus minus. What is the, what do we call it? So you have two decimal places, so become 0.03. So right now you have 1.21 plus minus 0.03. Any students have question?
So in the case where the uncertainty we get a 0, then we just add another significant figure.
Right.
Okay.
Okay, so everyone clear, yeah? I will not fill the table. I'll leave it with you. But what will I do now is I will guide you through the CI about plotting. Later, I will give you time to do. So when the R is now 16, right? Or 1.6, sorry. When the R is 1.6, you have the D is 1.2, right? Plus minus 0. How much is now? I'm sorry. 0.03 or what design I forget, is it? So you have to find first here where the R is 1.6. And the 1 over D squared is at 1.2. So here is it, right? Can you see the blue dot? This one is 1.6 and 1.2. Any students have questions until here? But then just now, if I'm not mistaken, we have 1.21, yeah, plus minus 0.03, yeah, just now. So I ever told you this one will be the error bar, right? So you have to, okay, your sketch will be something with a span like this.
Sir, but how you write the 1.21?
We cannot get 1.21, so yeah, I have to be wise also. You still take it as a 1.2.
Okay, sir.
Okay, and then the
Wait, sir, does that mean that it's like 1.23 or 1.24? Do we round it to 1.25? Then we just write it in the middle of the box? Or do we still round down?
I have to still run off there.
Round off to
You
what?
have-
1.2 or 1.25?
Sorry?
Just, for example, it's 1.24. So do we round it to 1.25? Because technically you can write the center of the box, right?
Oh, yeah, that's fine. You can do like that. Closer, right?
Yeah.
Okay. So no one have questions until here. Okay. The width of this have to be 0.03. It will be kind of difficult for us to draw because one box right here is how much? 0.1, right? Is 1.0 and then 1.1, 1.2, 1.3, 1.4, 1.5, right? Do you understand what I'm talking about? So to get 0.03 is kind of difficult. Maybe you can only like around half box only. But it's kind of difficult for this to be drawn, for this data, I mean. But probably for the other, it will be easier. Just now you have many rows to fill, right? Where is it this one? This one, I haven't calculated the others, right? So I will give you some time to calculate and write down the result first. Do you have any questions that you want to ask? Draw the best fit line and the
Sorry, still
worst
drawing.
acceptable line. Yeah, okay, I'll wait. Um, okay, I'll just teach you first about the best fit line and stuff, yeah. And I'll wait for you to draw, okay? Let's say you have the plotting already. For example, something like this here. This one is all of the coordinates that you have. What we call as a best fit line is make sure, okay, it's not a must. It is not a must for the line to pass through all of the true value, but then just make sure it pass through most of them or close. That is the best fit line. So what about the worst acceptable line? There are two versions of the worst acceptable line. It can be the most slanted or the least slanted. What do I mean by the most slanted? The most slanted is you go from the first point, the most right error bar, to the last point, the first of the error bar. You draw a line connecting this. What about the other points? We don't care about that. That is the most slanted. What about the least slanted? The least slanted means from the left of your first data to the most right of the last data. That is the least slanted. But for the worst acceptable line, you don't need to draw both. You just choose one, which one you're going to draw.
Wait, sir, best fit, it just has to pass all the lines.
Not all, but most of them. If you want to find gradient, the method is, let's say this is your best fit line just now. You should draw a triangle, a right angle triangle, and it should cover at least half of your line segment. To find the gradient, you should draw a right angle triangle, and it should cover at least half of your line segment. So this is how you indicate the examiner which coordinate that you are taking. So it's not right if you only write y2 minus y1 over x2 minus x1. You won't get marked from this. You need to show the triangle. Which one are you talking about? So that's how you get a gradient of the best fit line. And if your graph is right, here is being stated that the value is around 1.4 to 1.5. How come have 10 to the power of negative 6? Be aware with the y and the x-axis, they carry power. So try to check your gradient if it's in between 1.4 to 1.5 or not for the gradient of the best fit. how to find the absolute uncertainty of the gradient. The formula for the absolute uncertainty of the gradient is you can take gradient of best fit minus the gradient of the worst, or the worst minus the best fit. So after I subtract, if my value is negative, what should I do? You can ignore the negative. Please do so and tell me the result. But then just now your best fit, let's say your best fit, the gradient is 1.43, for instance. So now I'm waiting for your result after you subtract both of them. Any volunteer to tell me the answer?
So how much is the gradient just now?
Best fit should be in the range of 1.4 to 1.5.
Oh, okay.
Wait, sir, how do we draw the worst fit line for the last one if the first one doesn't have any of the bar thing?
You can just focus on the second coordinate, the worst and the best. The worst acceptable, so it can be the most slanted or the least slanted.
So we start drawing from the second coordinate.
Yes, right.
Okay. When drawing the line, do we have to like draw it until it touches the ends of the graph paper? Or like until it touches all the points and it's enough?
Just, yeah, if can, all of the paper, better.
Okay.
Okay, guys, any volunteer? No? Okay, it's okay. But then just want to remind you that it should be a 2 decimal place also, yeah. Should be 2 decimal place also. Unfortunately, they only have the method, but they don't have the answer for the uncertainty of the gradient. But then, however, it will affect your last calculations later, okay? So we still can check at the end. So if no questions until triple I will move on to DI. So I'm asking you again one more time. Do you have any questions that you want to ask?
Still doing so.
Okay.
There, can you show the mark scheme for the best fit line again? Okay, thanks. Can scroll down a bit. Yeah, thanks.
Okay.
So the mark scheme says for the worst acceptable line, it has to pass through all the error bars. So if the last one doesn't have an error bar, if the first dot doesn't have an error bar,
No, steepest or the shallowest possible line that passes through all of the arrow. You cannot pass through all, so I never do that. Usually I just take the right, the most left. But you will pass through the arrow bar also, isn't it?
I mean the
You
first
do
the
that?
first dot doesn't have an error bar because the uncertainty is so small.
Oh yes, it's fine. It's fine. It's too small to be drawn.
Okay.
Okay. Now I want to continue to this, yeah, di, yeah. For di, just now your gradient is equals to 4 times the resistivity times length over pi. Gradient. That m is gradient, yeah. So the resistivity is equals to m times pi over 4L. So your gradient will affect the resistivity. If you not take it seriously just now, you cannot find the resistivity. And if you want to find the percentage of the uncertainty, how are you going to calculate it? So it means resistivity, fractional, uncertainty of the gradient over gradient, plus uncertainty of length over length, right? Why I ignore the pi and the 4? Does the pi and 4 has any uncertainty? No, right?